Hello everyone. Today we're going to look at usaco-training again. Okay, so in this problem, we're given n positive integers on a 1 times n board, and there are two players that are going to be playing the game on this board. So player 1 starts first, and the players, they move alternatively by selecting a number from either left or the right side. And then after they select a number, they would delete that number from the board, and they would add that number, or that number would be added to the player that chose it. And a player wins if his sum of numbers that he chose is greater than the sum of numbers that his opponent chose. Okay, so all the players are going to play on an optimal strategy, meaning that their strategy is going to win them the most points. All right, so not only do we have to implement a optimal strategy for player 1, we also have to make one for player 2. So then we're given the input, and we want to print out the score of player 1 and the score of player 2. And over here, for example, we're given a 1 times 6 board with integers 4, 7, 2, 9, 5, and 2. Okay, so let's actually take a look at that over here. So right now, we have our n pieces. And since we know that, or what we can do is that we can actually break this into sections. So for example, you can see that we can basically consider a subproblem of the total array. So then our answer over here would be the entire grid. So we can define as a range. So this would be a range, and whatever this range contains is going to be the answer for the range. So then we can define over here dpi equals to the score of or what we can do here is that we can make this the difference of the scores. So the basically score 1, which is the score of player 1, minus score of player 2, or basically this would basically be our DP state over here. So then, for example, if you consider our input, we're given these 6 integers, and instead of having dpij, dp16 equal to 18, we would have it equal to 18 minus 11, which is going to be 7. All right, so basically this would just be the difference between the scores of player 1 and player 2. Right. So now that we define this, what we can do is that we can first consider dpii, which means that this is just going to be one cell. Okay, so this is just going to be, you're not going to consider the other ones, you're just going to consider the game if you only have one cell. Well then over here, your dp value for this would be equal to, let's call this a of 1, a of 2, dot, 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 and then over here you have a of n. So then your dpii would be equal to a of I, because if you just have one specific subproblem, then over here it would be always optimal to pick a of I over here, since it's positive and that's the only choice you have. And so then over here your score 1 will be equal to a of I, and since there's only one element, then your score of 2 would be equal to 0. So then the difference would be a of I. Right, so that's your dpii. Okay, so now how are we going to make, for example, how are we going to take whatever, let's just say this range where we have 4 elements. So again, right now, after we consider this, the size of these, or let's actually try out. So we have, so, whoops. Okay, so we calculated the answers for just one cell, which is basically DPII. So now how are we going to make, for example, something of length 2? So to do this, let's first consider something of length 2. So we have 2 cells. Okay, and either this one is going to go to player 1 and this one is going to go to player 2, or this one is going to go to player 1, or this one is going to go to player 2, right? Since you can only take from one end and the other would just go to the other person. So then we have dp I plus 1 equal to the maximum of a of I, since right now, if we have this, and let's call this AI, this is AI plus 1, AI my I plus 1. So over here, the difference would be AI plus 1 minus AI, and over here this would be AI minus AI plus 1. So then this would be equal to the maximum of AI minus AI plus 1 and a AI plus 1 minus AI. Okay, so now we know what would be for size 2 over here. So let's erase this. So let's actually redraw this. Right. That's fine. So right now, again, we have, let's actually just erase it too. All right, so over here, we have, again, our n numbers. So right now we have each of our size 2s. We calculated the answer for this. And now we're going to try to make our size 3s. All right, so if you consider this, let's actually use up here. We have 3 elements. We have to take this one, or we're going to take the last one, since we have to remove it from either end. So then, notice that we already calculated our answer for size 2. So we have our dp. Let's say this is I plus 1, I plus 2. This would be dp I plus 1. And if we have over here, again, this would be I plus 1, I plus 2. And then we also calculated this, which is going to be dp I plus 1, I plus 2. So now, since we're only either going to take this cell or we're going to take this cell, then what we would do is that, you know that this is I plus 2. This is AI. So then, assuming that we're going to take the first one, we would basically add AI to our first, to add it to our first player. And then, assuming over here, we already calculated something for score 1 minus score 2. But notice that since we're adding another element, it means that the previous, or means that it would basically invert. So over here, let's just say, in this range, we took AI plus 1 as for our number 1. So this is going to be 1, and this is going to be 2. So then over here, our dp value would be equal to AI minus AI plus 2. So this would be equal to dp I plus 1, I plus 2. But then, since we're adding another thing, then all of these would basically go in reverse, since this is going to be our new this is going to be, what do you call that? So over here, this 1 is going to be our new first player. So then the previous first player over here would become a 2, and here this 2 would become a 1. So then to do this, then over here, it would be AI. This should be I plus 1, my bad. So this should be AI since we're taking it for player 1. And then you're going to subtract dp I plus 1, I plus 2. So then this would be a result if we choose to let player 1 take this value. All right, so that's for that. And then again, similarly, if we want player 1 to choose this, then our value would be I plus 2 since we're choosing it for player 1. And then we're going to invert it over here. So then this would be minus dp I plus 1. So then after this, since we want to have the most optimal play, then we're going to have a maximum of what we have over here. So this would be AI minus dp I plus 1, I plus 2, and I plus 2 minus dp I plus 1. So then we would set dp I plus 2 equal to the maximum of this. Okay, so right now, again, we know how to calculate it for size 3. So now notice that this is basically extending to a general value of size. Since every time we have n things, so we have n things, we're either going to take the first or the last. So then to do this, we can basically make a general dp transition. So then dp ij would be equal to the maximum A, since we're either taking AI or HJ. So this would be AI minus dp I plus 1 J or AJ minus dp I plus 1. All right, so now that we made our transition, the overall difference of our whole thing, so then over here, our answer would be equal to our dp from 1 to n. But notice that this is going to be the difference of the score 1 of, it's going to be the score 1 or the score of player 1 minus the score of player 2. So now how are we going to find the score of player 1 and the score of player 2 that we're given this? So we can actually analyze this. So you know that when you add these two scores up, this is going to be equal to the total, or basically the sum of AI. Since we actually have to pick every single element, each element either goes to player 1 or player 2. So then we can make a statement that S1 plus S2 would be equal to the sum of AI. And then over here, whoops. All right, so we also know that S1 minus S2 is equal to answer. Or over here more clearly, let's actually erase that. Over here. All right, so S1 minus S2 is equal to dp1n. So we can calculate some of AI. We can also calculate this dp value as we did above. Then if we add these two up, we're going to get 2 times S1 would be equal to the sum plus dp in. All right, so then again, we can calculate this value. So then to find the score of player 1, would be just equal to the sum plus dp1, and then you would just divide it by 2 since you have a 2 over here. And then to find the score of player 2, so now we can find this, all good. So to find the score of player 2, this would just be equal to the sum minus the score of player 1. Alright, so that's just for the explanation, and let's get coding. Alright, so over here, let's make this a little bit bigger. So we have the maximum value of n is going to be 100, well, only 100, and we're going to have n, each of the values, and we're going to also have dp of n. Let's read n, and for each element, we're going to read a of I. So then first thing we need to do is to calculate the sum of everything. So then as we're reading it, we can just add ai to the sum. And we can also set the base case. So dp of ii would be equal to ai, meaning that you would give ai to player 1. So then we're going to loop through all ij starting based on their size. So we can just loop through I plus r from n to 1, and j from I plus 1 to n. Alright, so like I said, dpij will be equal to the maximum of ai, assuming that we're choosing ai, minus dpi plus 1j. And aj minus dpi j minus 1. So this case is if we're choosing from the front of the array, and this case is if we're choosing from the back of the array. So then we have our S1, which is going to be equal to dpij plus the sum, dp1n divided by 2, and our sum 2 would be equal to, the answer for player 2 is going to be equal to sum minus S1. So then we're just going to print it, and that's it. So let's run this. Alright, let's get this. 1811, very nice. That's over here, game 1.n, read, and game 1.l, write, stl. Alright, let's submit this. Alright, so let's get into here. Let's enlarge this actually. 1 second. Alright, there we go. Okay, so this is game 1 actually. Submit this. Okay, so everything is correct and it's actually running pretty quick. Okay, so that's it for today. If you have any questions, feel free to leave them in the comment section below. Bye.